Okay, so let's get started. Today I'm going to be talking about WebAssembly, Rust, and the state of async and await in Rust and WebAssembly. And this talk is going to be focused on actually using WebAssembly to write back-end applications as opposed to front-end. So that's something interesting that we're going to be talking about. So we're just going to have a quick refresher on WebAssembly, go over how you use it and what it's used for, talk about using it on more than just the web, and then we're going to talk about some concurrency models, and then we're actually going to go over how we can make a website that runs WebAssembly on the back end. So a little bit about me first, and I know we kind of did introductions, so I'll go over this quickly. My name is Clayton. I'm from Provo, Utah, but I currently live in Rome, Italy. And I'm 16 years old. I've been programming for about 7 years on a lot of different things. My languages of choice are Rust, Python, and Go. Also Passerin, which is a programming language I'm currently developing. And I'm interested in reinforcement learning, which is like a branch of machine learning, programming language design, and graphics programming. And I like the low-level control that Rust gives you to do these things. So let's get started. So a quick refresher on WebAssembly. WebAssembly is an open standard that defines a portable binary code format as well as interfaces for interactions between programs and their host environment. And this is just the basic definition on Wikipedia. And I kind of want to highlight two things, right? So first, this is like an open binary code format. So WebAssembly, although it's usually tied with the browser, there's nothing specific to WebAssembly that makes it the case. And it also defines a set of common shared interfaces between programs and their host environment, which allows you to perhaps run a WebAssembly binary in different host environments. So how do we use WebAssembly with Rust? Well, Rust-C, the Rust compiler, targets WASM 32, unknown unknown. And when it does this, it basically just compiles out a WebAssembly library with some JS bindings. And this library can be slotted in next to some JavaScript and called normally. And tools do exist to automate different parts of this process. We'll be using one called Wrangler later on. But overall, I found the experience to be pretty frictionless. A Google search and like quick tutorial are all you really need to get started. There's nothing heavy to set up other than the Rust toolchain. So when you compile a Rust project, depending on how you have the compiler set up, it will produce a set of JavaScript bindings and some WebAssembly, and this will then be bound together and run on whatever browser engine you're using. All major browsers support WebAssembly at this point, but a common engine is V8. That's just like a JavaScript engine, also has WebAssembly support, which is pretty nice. So what is WebAssembly useful for? Well, we know that cross-platform applications built on web technologies are kind of bloated and slow and awful generally. So this doesn't have to be the case. WebAssembly is really useful for running native code on the web. If you've ever used like Figma, that is an application that is written in C++, but it targets WebAssembly, which means you can use Figma, which is written in C++, in your browser, and it's really snappy if you've ever used it before. And WASM, as we kind of mentioned earlier, is more than just like built for the web. It's a general portable binary format. So we can use WebAssembly for more than just web applications, speeding up web applications. We can use WebAssembly to run native code anywhere, because it's really just another compilation target. This includes mobile, desktop, even server-side code, which is what we're going to be doing, and it's pretty interesting. So WebAssembly, without the web component, is just assembly, because it's an open binary format supported by every platform. And it's about as fast as native binaries. If you want to look closer into performance, from what I've benched, it's about 1.7 times slower than native code, which is a given because it's not exactly tailored to the machine. The way it works is WebAssembly is just parsed by V8, and then the just-in-time compiled code is emitted. And it's not specifically optimized towards the platform, but it's usually pretty fast on average. So V8, the JavaScript engine, has support for something called isolates. And now isolates are basically processes that can run multiple instances of user code. So traditionally, you buy like a VM box somewhere, and if you want to run like a different web application, you need to start a new process, and each of these processes has some overhead. And on top of this, the scheduler, the OS scheduler, has to switch between processes, and it doesn't really know like what process it should switch to at any given moment in time, because it doesn't really know much about what the process is other than it's running, or that maybe it has some incoming like network requests. But what the V8 JavaScript engine can do is it can run something called an isolate, which is basically a single process, but you have maybe hundreds of different instances of applications that will be woken up and put to sleep at different points in the user code's sort of life cycle. And this can be used to run like many, many different applications on the same server if you're doing some sort of microservice or serverless application. So now let's take a little detour and talk about async, await, and other models of concurrency. So concurrency is how different programs interleave sets of instructions or series of data manipulations. And something that's important to point out is that concurrency is not the same thing as parallelism. If you've ever written a rendering engine, you know that they can be written in a concurrent manner, like if it's a ray tracing engine, because you can have rays that cast out to the scene, and each ray doesn't depend on any other rays to determine what color that pixel on the screen is. And for this reason, it's both concurrent and highly parallelizable. If you have something like a generator in a loop, this can be written in a concurrent manner in some languages. But this is not parallelizable. So a generator is, again, like a function that yields something, and it generates kind of like a stream of values. And if each value in the stream depends on the previous value, it's not easy to parallelize. So both these things are concurrent, but both aren't parallel. And it just really depends on how parallelizable the problem is, rather than whether or not the problem can be expressed in terms of concurrent code. So in Rust, concurrency uses async and await, which are kind of two key words that create and wait for promises or futures, which are basically promises to evaluate some code in the future. So whenever you run asynchronous code, you're basically building kind of like a big call stack or like a big graph of functions that is evaluated, like depending on your evaluation context. And async shows that a function is asynchronous, and await just unwraps a future. And asynchronous functions return futures, which are these promises to execute some code in the future. And if we have an asynchronous function, we can just call .await on the function, and that will, to the type checker, basically give us the value that it returns, which would be an AND string in this case. So concurrency in JS is very similar to concurrency in Rust. We have async and await, and instead of being like a postfix operator, await is more of just a standard keyword. So to bind, like, let's say this function to Rust, so we can use it like this function, we just define an extern C block, and we use WASM bindgen to create the bindings. And this basically just creates a function that can be called from Rust while respecting JavaScript's concurrency. JS value is a special value defined in WASM bindgen that is owned by the JavaScript application that's kind of calling the WebAssembly. And JS value can be unwrapped. So this took me a little while to figure out, But futures in Rust are basically called promises in JS. So they're the same thing, just different names. And the create WASM bindgen JS future converts a JS promise to a Rust future, which can then be awaited, as we've seen. A JavaScript future in Rust of this type, when awaited, will return a JavaScript value, and this JavaScript value can be converted to a Rust value with a string. So if we have like a JavaScript promise that we pass to Rust, we need to convert it to a future, then await it, then convert it to a Rust value to use it from Rust. Or we can just manipulate the JS value itself directly. So let's get into building a website with Rust, WebAssembly, and Workers. So I just want to show you my personal website that I wrote with Rust and WebAssembly on the back end. And it's a website and a knowledge base, and it's built with the same technologies outlined in this presentation. And the idea behind the website is I just wanted a place where I could write different things, like a blog, I guess. And a few things you can do. You can sign in. And the way it works is it has a HRDB, like a human readable database. And this allows for editing pages with a graph-like structure. So you see that we have pages nested in pages. And we can even go in and edit different pages. So like, yeah, it's just Markdown. And then we can save it. It's nothing too complicated, but it's interesting in the way it works, and I'll get into that some more later. So it's basically Rust and WebAssembly, and it's running as a backend using Workers KV. That's the backend database. And I just want to talk about CloudFlare Workers. So Cloudflare, as you know, is like a general purpose edge network that does DNS protection. And because of this, they have like servers all over the world. And what you can do is you can actually write WebAssembly binaries or WebAssembly applications and push them out to the servers on their edge network. And when you do this, it's pushed out to all the edge nodes and it's ran in an isolate. And each edge node runs thousands of different worker isolates. And then you can, they also provide a distributed key value store called a namespace. And you can use this namespace to write more complex applications as like a database, if you'd like. You can also use normal database technology, but that's just an option they give you. So let's do some programming. So yesterday afternoon, I wrote some demos that we can go over. So let's see. So Wrangler is a sort of command line tool that will compile WebAssembly projects for you, and it will kind of publish them to run on Cloudflare's edge network. So I have this project open called Rust Worker template, and I'm just going to go over the basic way it works. So we have our wrangler.toml, which is basically just a configuration file. And the most important thing here is that we have the type set to Rust. And this tells Wrangler that it's going to need to compile some Rust code and link the generated WebAssembly library to some JavaScript. To call into the WebAssembly library, we basically just have this Node.js application. And it's adding an event listener onto fetch. And it's just basically binding the WebAssembly module, extracting this main function, and it's calling out to main from WebAssembly. And this function just returns a string, and the string is passed out as a response. Then right here, all we're doing with the request is we're grabbing the path and the method, and then we're doing this really hacky. I would not recommend actually just including a string. I would recommend like loading a template and then filling it out. But we're just loading a string here, and we're just saying the method and the path that we got. So if we run this with Wrangler dev, it will compile our project, and we can take a look at it. And we can see that it will just tell us where we got it. So like hello, and this is really all we need at this current point in time. And so we can use this sort of template to build more complex applications. I actually have fleshed this out into a smaller version of slightneck.dev. So let's take a look at the code. And so Wrangler.toml is similar. Something to notice is we've bound a namespace. So this is basically a database. And these would be like tags, like hashes, that would point where to look for the database. I've just taken them out for privacy. So our cargo.toml looks pretty similar to the last one. We're just telling the compiler that this is a library and to configure this allocator. Now, because WebAssembly is kind of a lighter binary format, we need to reduce the size of the Rust runtime. So we can use wealloc, which is a custom allocator that basically is just a smaller version of the standard allocator that reduces the size of the Rust runtime. And even Rust has a runtime, surprisingly. Just a very small one. So to call into JS code asynchronously, we need WASM bindgen, and we also need bindgen futures, which allows you to bind promises and so on. Then for parsing, we're using URL and a markdown renderer. And then to interact with JS, like data types in the standard library, we're using JSSys and WebSys. So our worker looks pretty similar. Something to notice is that we have await here. So this main event is an asynchronous function as defined in Rust after it's bound. And we're returning a response as the other one. Let's see. So when we get a request, we parse the URL and we get the path, and we also get a method. And the method is just get or post and so on. And the path is the stuff after the URL, as we saw before. And what we do is we just respond to this request by pattern matching on the path. And depending on where we are, we either render the page out as markdown, or we update the page if we've edited it. And this is just formatted, again, using a static string. Do not recommend use a templating engine. Then to update the website. So I'm just going to show you the website really fast so you can get an idea of what it's like. And then again, it just compiles it. Optimizes the binary with WASM opt, which is basically just an optimizer that reduces the size of the binary. And let me see. I need to be on the master branch because it has the tokens. So then we can check out the website. And it's a bit slow to start up, but you'll see it's just a website with some markdown. And we can edit the page. Let's see. I edited the page. And when we update it, it will update the markdown. So the way this works is we need to access the KV namespace. And in JavaScript, if we want to access the namespace, we use await. We have the namespace name, and then we have .put. So basically, all we're doing is we're grabbing that function from JavaScript. So we're making a type called document, and then we're binding these async functions get and put, which are basically get and set functions. And then we have these two methods for convenience, which are needed if you're writing more complex applications. So this will allow us to read and write data from our namespace. Once we've read the data, we just use pull down CMark to parse the markdown into some HTML. And to get form data, we're using this extract function, which basically just extracts the form from the request, and it gets the content field on the form. It's pretty standard stuff. So as you can see, writing an application with Rust and WebAssembly is not different from writing a web application in other languages. The only thing you need to watch out for is the points where you're crossing the boundary between WebAssembly and JavaScript. And you just need to make sure that you bind all those points. So we have a WASM bindgen here because we're binding this function to be accessed from Rust. And we also have this bind function here to bind these functions on the document type when we're updating our database. And just to show you some more, I have this really big markdown document. And let's copy it. And we can run it. So let's try rendering this massive markdown. Okay, it's still compiling. Rust compile times are interesting. I think there's still some work to be done in that respect compared to some other languages. So let's plop in this giant markdown document. Okay. And this is just John Gruber's very first post where he outlined what markdown is. And we can see that it renders fine. And that was fairly fast. So yeah, that is the demo. Let's move back to the presentation. It's always interesting doing things live because you never know. You can practice and plan, but you never know exactly how they're going to turn out. I think I covered everything that we needed to go over. Okay, there it's loaded. So, we ran our worker with Wrangler dev. You can also do, I should mention, Wrangler publish, and it will push out your application to any edge. This is what pushes out your application to web servers. And if you link it up with a domain, you can access it from anywhere on the internet. I was just running it locally. So key takeaways. WebAssembling is a great new technology that will play a critical role in future projects. And I might be a bit biased, but from the little that I've used it, I found it to be insanely useful. And it really just allows you to write Rust, or any programming language for that matter, compile it, and not worry about dealing with other programming languages for that platform. So you just write Rust, a tiny bit of JavaScript glue, and then all of a sudden all of your application can be written in Rust, and you don't need to worry about JavaScript at all. It can be used for more than just web-facing applications. So usually WebAssembly is used in the browser, but we can also use it for server-side. And it's a great way if you want to run sort of a microservice architecture with many different applications running on the same server. Rust also has a really good concurrency model. Async await is kind of the golden standard at this point. After people kind of realized that callbacks were more like continuation passing style, which is like a compiler level optimization, than an actual paradigm to write code in. And we also saw that Wrangler is a very nice way to get started with WebAssembly for more than just the web, and that it makes compiling and deploying a back-end WebAssembly project very easy. So thank you for listening. Elsewhere on the internet, you can find me at SlightKnack or Isaac Clayton. To contact me, hello at slightKnack.dev. My website was slightKnack.dev, and I'm also on Discord. And I'm going to upload these slides sometime later today. So if you're interested, I guess follow me on GitHub, and you'll get notified when I do. So I'm ready for questions, comments. Thoughts?
Very nice presentation. Thanks.
Thank you.
Yeah, that's actually what I was going to say is round of applause. Woo!
Yeah, it's hard to do that on Zoom, right?
Yeah, and it's also, I should mention that it's 2 in the morning where I am right now.
Wow.
You're pretty
so
sprite and chipper for 2 a.m.
Right.
Well,
Used to early morning seminary, I guess.
so that presentation was absolutely amazing. Very well done. Thank you very much. Unfortunately, I missed the first couple minutes of it because I was trying to deal with the technical difficulties, and the first 4 minutes of this, unfortunately, the recording crashed and we didn't get it.
Okay, so actually, when I saw that we were having trouble with the recording, I actually recorded it as well.
Okay, cool.
So I can send you that.
Excellent. That would be awesome.
So does anyone have any questions on WebAssembly or using Wrangler? I wasn't exactly the clearest when I did the code demo, so if you have any questions about what any of that was doing.
How do you raise your hand?
Well, I think there's actually a reaction.
Just speak up. Just butt in. We're going to have to deal with the Zoom and the weird awkwardness of the online only.
So I've tried looking around a little bit, and I'm not sure if it's just not supported or if I'm just not finding a clear answer on it. But I'm really curious about the way WASM and memory interact. So say I'm receiving buffers and that contains some message that I want to do something with. Is there a way to give WASM access to that buffer, just like as a byte array type of a thing, without copying it into a different memory space?
So from what I understand, the way that memory is passed between WebAssembly and JavaScript is that you have this kind of big array of numbers, basically. So just this region of memory. And data can be moved from JavaScript into that buffer and out of that buffer into WebAssembly and back and forth. And that's sort of what WASM bindgen does. It automatically sets up those interfaces. So if you can go more low level, and you can manually manipulate that kind of buffer of memory itself, So I imagine you could actually just store you could write to that shared memory buffer, your stream of data, and you could read it from WebAssembly without copying it. But you'd have to do some more sort of low-level work around that rather than just binding some types and hoping for the best if you want to control not copying the buffer.
Yeah, sounds like what I want to be able to do.
So if you're interested in low-level details, we had a presentation on WASM in April, and I just posted the playlist in the chat, so check that out.
Okay, thank you.
Let's see. One question I have that is not related to WASM, so I'm going to go outside the bounds of the question you have deemed acceptable because I'm a rebel like that. You're living in Rome right now. What's up with that?
So basically my dad works for the U.S. Department of State. So as long as I can remember, I'm from Utah, right? So like I go back in the summers occasionally, and I have family there. But as long as like I can remember, we've been like moving every 3 or so years around the country. So I've lived in like Brazil, Argentina, Spain, Indonesia, and Rome. Well, that's where I am now. So, and I started sort of programming. I'm like pretty much self-taught, like for what I've learned so far. And I find it something that's kind of like a constant in my life that I can do no matter where I am. I mean, you just need not even an internet connection, just like an editor in your set. So Rome, so far it's been interesting, especially with lockdown. The government keeps on releasing decrees about school and stuff. So like, it's been a bit of a mess, but I'm here, so there's not much I can do about it, I guess.
Are you getting to enjoy the pizza? The real pizza?
Oh yes, there's this little store on the corner down by like the river, and the pizza there is really good. It's, I don't know, I'm always tempted to just like walk down there and get some.
Man, I actually visited Rome in 2016, and the Gelateria del Viale is one of my favorite places there. So it's kind of interesting because Rome was one of the cities that my wife and I really felt like, you know what, we could probably live here. This is comfy.
Yeah, and I think something for having like moved around a lot, wherever you live, kind of like feels the same-ish. Like, sure, like each city is different, and there will be different things you have to deal with. But wherever you are, you're still going to be like going to school or to work, eating dinner at your house, or like it's not much different like inside your house. Like it feels like you could be anywhere until you like open the windows or go for a walk. I don't know. Maybe that's just me. I'm like blind to the many different aspects.
Off of that,
different strokes for different folks.
Off of that topic,
go ahead.
Is Jeff on? Our next presenter. I am on. Oh, okay. I don't see your name. Oh, there I do. Okay. Yep. Now you're showing up. Cool.
Looks like Isaac's not the only blind one.
All right. Well, I'm thinking maybe we should go ahead and move into the next presentation and then continue on with the chatter afterwards, just because I know some people are here because they were expecting to see that one as well, and I don't want to... I really love having the chat and everything. I just want to make sure that we manage, or I mean, we could put it to a group vote if we still want to just chat for a little bit before we move into the next one, but I figure it might be a good time to do that.
Do the next one, then chat after.
Alrighty, cool. Well, thanks so much, Isaac, and Jeff, take it away.